How many people, when I say anycast, know what I'm talking about? I expect a decent number of hands. Oh, less than I thought. Okay, good. I tailored this talk well. So basically, this is an intro to the subject. If you don't know what that word means, congratulations. And judging by the hands, that's a decent number of people. So, cool. So, let's get going. We're going to do that. Question, so we're going to go over what it is, why does it exist, who does it, why do people do it, how expensive is it if you wanted to do this, and how you can do it. And then we'll do a live demo as to, hey, look, it works. Congratulations. It's not rocket science. I'll walk you through it. If you take one thing away from this talk, just one thing, there are other operating systems available. So for those who don't know, yes, Windows, Mac, Linux, all this other stuff. There are a bunch of BSDs. I've been into BSDs for the last, well, a while. But the point is that these things exist. If you don't know about them, you should look them up. If you're watching Netflix, you are using it. Anyways, and just to be clear, I'm talking about OpenBSD in this. It's going to be really light on the actual technical because there's concepts here, and given the crowd and the introduction in 20 minutes, it's going to be, this thing exists. It's not going to be tailored specifically to a bunch of tech. This will be generic, and any modern operating system, you can make the thing work with a bunch of different systems. So, one slide. I think I've got 2 slides on anycast. As you can see, basically, anycast is a very fancy way of saying one IP address does not equal one host. So the same actual IP address is available in multiple different locations, and it's all using the same IP address. And this is usually referred to as in a global routing table environment. So basically, ISPs, or usually ISPs or other large networks. So big names in the industry will be using it. A really simple example that they're very public about and have done talks about is WordPress. They do enough traffic that they have an anycast system. Wikimedia does an anycast system. Content delivery networks, all that stuff. We'll get into it. But the concept is literally you have the same IP address, and instead of having, I have this IP address, it goes to that host anywhere in the world, right? So like if I ping, well, the really good example, 1.1.1.1 is anycasted, which means that from where I am right now, that ping response is going to be coming back to my machine from one location. But if I'm in South America or I'm in, Australia, it will be the same address, but it'll be a different machine responding. So that's what anycasting is in a very, very simple nutshell. You use it to lower latency and to do load distribution, generally speaking. There are other edge cases and all this other stuff, but it's not about, so notice I said load distribution, I didn't say load balancing. And that's an important thing because they're not the same thing. Load distribution refers to, yes, traffic from Australia will generally speaking hit the node in Australia. There will be exceptions to that. And you don't control what that happens. So you can influence that decision, but at the end of the day, the world is going to send you traffic however the world wants to. A good example is here in town, I'm on a particular cell phone network. It will transit that data all the way to Calgary and then back, regardless of whether or not I'm talking to the thing next to me. And that's the point, is like you don't get to control where traffic gets sent to you. You just get to say, I'm here, 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 and here, and then there are optimizations that will try and route that to the closest machine. I cared because I wanted no single point of failure other than my own stupidity. And that's an important distinction because tech is tech. You can make systems really, really reliable, right? Like you can do good hardware, good OSs, good systems, redundant everything. You can make them last, 10, 15 years before you have a fault. But at some point, the point of presence is going to fail. And I basically wanted to set it up so I didn't have to care if a provider went down. Worth mentioning, volumetric attacks. There's a lot of, if you are popular on the internet and you have some controversial ideas or you piss off the wrong people, you're going to get a bunch of TCP SYN traffic and you're going to get basically We're going to throw packets out the door at you and see if we can fill your internet pipe. This helps with that. It doesn't cover all of it because there are going to be replay attacks. So that would be like, oh, I'm going to spoof traffic as your source and query all these DNS servers or whatever else, and those servers are going to come back, and that'll be distributed if they do it properly. But if you're just throwing packets out the door and you have really big internet pipes, somewhere like Indonesia or these days China to some extent, these are large networks that will easily fill couple hundred gig pipes of just TCP SYN, and we're like millions and hundreds of millions of packets per second. So this helps with that because if it is that directed SYN flood attack, it's likely to hit one node out of X. So Australia might go dark, like your service might not work in Australia, but the rest of the world isn't even impacted, as an example. So there are some mitigations that way. It's not always true, but it's useful. There are, yeah, you can read. I'm going to skip through this quickly. Stuff will go down. There's standards. At the end of it, stuff's going to go down. And there are some distinctions here: availability, resilience, and reliability. These things matter. When you talk about anycast networks, you're almost always actually caring about these topics as opposed to just saying, I can make it work faster. Because anybody bothering to do this is trying to solve for a problem that is not necessarily the most common. You can scale to hundreds and hundreds of gigs a second concurrently with one physical pop, no problem whatsoever. This is bigger than that and also has different properties than that. So you might want lower bandwidth, but more availability or lower latency. So you have multiple pops to get around it. So these are just random. I think that one's Vultr and that one's Equinix. But the whole point is that you've got options. You can own your own hardware. We'll get into when you say you run your own network, what does that mean? Does it mean you own the machine room? Does it mean you own the generators? Does it mean you own the IP space? Does it mean you have co-located hardware? These are all distinctions that matter to some people. I'm trying to flag this as you can start small in the anycast world, and it is kind of interesting. There are providers, as in VM providers, like we're all familiar with, that will give you a VM and then also peer with you, and you can run BGP, and we'll get into it. But you can also do that from all these little VMs. That's kind of neat. So I'm not going to go through all these, but basically what I was trying to solve for and what I'm trying to make a point of, every big network will fail at some point. And it's not about, oh no, this one pop failed or whatever. It's going to be the person pushing a config change. AWS has done it, Rogers has done it, every internet service provider has done it. It will happen, and it's not a question. It's a question of when, not if, and that's okay. So if you want to solve for it, solve being very definitively not standardized, just run in multiple different providers, right? Anycast allows you to do that. There's other solutions available. Anycasting allows you to do that with very specific properties, like the same IP address, as opposed to using DNS and having multiple A records, as an example. So, yeah, gets used some places. Mainly content delivery networks, critical infrastructure and DNS-related stuff, any large network doing stuff, yeah. All right, questions, comments, concerns, because I'm like, this is not that hard. It's really not that crazy. Okay, cool, I'm just gonna keep going. As an example, you can see, so people who don't know this is totally fine. This is just showing propagation of routing, and each node represents a network. And these are, I'm not gonna get into the whole thing. You can think of it like the organization. That could span the globe. It could also be like one machine over here. And so what this shows is kind of how when you talk to this network, how do you get there? And so you can see there is one that's in the middle there that has a relationship to a bunch of others. That's almost always going to be an anycasted system. It's not always going to be that case, but it is generally going to be the case because a lot of these networks in the middle there are geographically spread across the entire globe. Like, you're not talking to the internet exchange directly in China on the same piece of equipment that you're doing it in Shanghai as you are in London. It's just not going to happen. You could theoretically do it, but you would want multiple servers to be able to do the thing. So this kind of And by the way, that's Cloudflare as far as the one-to-many relationship there, as an example. Same thing in reverse. So this is a looking glass. For people who don't know, basically, you go out, talk to a bunch of different places and say, hey, trace effectively, not actually the case, but effectively trace route, how do you get to here? And so on the left-hand side, you can see all these different networks, and then the path that they take to get to the end network. And so you can see that they all coalesce into this one, like, many-to-one relationship, and then go to the one-to-one. So that would be like the relationship that Cloudflare has with this particular network, as an example again. That's me at the left-hand side. Instead of just letting one, you can go to Cloudflare and pay them an egregious amount of money for them to do that, or you can do it yourself. This is the same thing that way. Notice that the network's a lot smaller. It's also a lot deeper. Really, when you get into this kind of scale, as far as the internet is concerned, you're paying for how close you are to tier 1 providers and how low is your latency and where are you physically, more than you're paying for other things. Because it might have to take 5 different hops to get to somebody as opposed to like 2. And the same thing, you can see over on the left, there are 3 entry points into my network as opposed to a bunch, but these are 3 different networks. And just to be clear, we'll go over them very briefly, but like, this is Amsterdam, New York, and Toronto on 3 different providers, 3 different VMs that I'm paying like 20 bucks a month for, or something similar to that. And they're all advertising my space. It's unlikely that all 3 of those are gonna fail, because the only thing they have in common is the administrative controls that I have, right? So if, as an example, one of them is a company called Vulture, they run Constant, there's a bunch of people in the room who know they are, doesn't really matter. If their entire network goes dark, I don't care. And that's useful in some ways. Yeah. So, it's expensive to get your own v4 space in North America. It's cheaper than in RIPE. And so it's cheaper than Europe, is I guess what I would say. Europe and not Asia, but definitely the Middle East. The annual fees really kill you on RIPE. They decided to go with a billing model that was everybody pays the same amount, whereas the North America regional registrar, which is where you go if you want address space, they decided to split it so that the big people were paying a lot more and the little guys got a break. So is also use v6, please. And this is, again, really ballpark my costs to just do this stuff, but you can make them higher or lower, yeah, adjust accordingly. The ASN and the IP space, that's what we went over before. Again, VMs, they're not that crazy. They do only charge, generally speaking, for egress bandwidth, which is really handy, because, yeah, there's reasons for that. And you can obviously do physical if you wanted to. Like you could, the low end, those are the low end, like, ballpark prices, as low as you can go right now. But if you are interested in this, take a look at bgp.services. It's a website. There are other lists available, but this is where you can go and get VMs or co-located hardware or whatever else, and they say, we will offer this as a service, which is kind of nice because, yeah, this is available, but it's not easy to get into. You'll find a bunch of different providers, like content delivery networks, usually have a sister company that is actually running bare metal next to the internet exchanges. So a lot of the content delivery networks, they have, why would I'm doing the thing, right? Like I have to serve this content. Why don't I just put some machines over here? So there are some companies that do that. Actually doing it, it's just BGP. Very fancy way of saying, hi, I'm here. I'm pissing off every network engineer ever. It's fine. It's generally speaking true. You can just basically run a protocol. You run a program, it advertises your space at the very low end. And then, yeah, there's details in there. There are RPK, so because it's the global routing table, you gotta think about security. There's a push these days for RPKI, which is basically routing public key stuff and validation. It's not a web of trust, it's top-down certs, sort of like CAs. The trust anchors are the regional internet registries. So you're already getting your address space and your ASNs from them. So there's a push for that. Nothing's stopping me from saying, hi, I'm Google. And if somebody decides to believe me, then they're going to route traffic that was originally meant for Google to me. And this happens at scale. So a lot of the incidents before, like Cloudflare recently, a Brazilian ISP made a mistake. That shit's going to happen. It caused an issue for like half of Cloudflare's customers for a period of time because people picked it up, and then that propagated. And so traffic ended up going somewhere it shouldn't have. So there's issues here, and it's a big, big thing. If you're interested in networking security, please consider global routing table security as something to work towards, because we could get better at it generally. So I use OpenBSD, doesn't really matter. I'm going to skip past most of this stuff. The biggest thing is BGP runs on, generally speaking, port 173, well, 179. It's a TCP protocol. There you go. And you need to be able to talk to your machine, right? So you need to get SSH or a VPN or something else. So if you go to these machines, say you have 3, you can either, if you have a very static, like you're running S3, let's say, an S3 compatible system, you're just serving flat files out the door. That's fine, and you don't need to do anything special. But where's your login credential? What happens if they log in over there, and then they use a VPN, or they're on a mobile network, and their routing changes, and then they appear on this other machine? You need state internal to your own network, or your own application, that actually keeps track of anything you want to care about. So state becomes a problem. And then you got to have these machines talk to each other, right? So how does the machine over there know to talk to this one over here? You get into internal networking and state. There's a bunch of different options. Yeah, certificates, VPNs, take your pick. pfSync is basically, you can read on the screen in general, but I would phrase it as it is a protocol to sync state tables for the PF firewall. If you're running Apple hardware, or Mac in particular, you're running PF. FreeBSD has it as one of the options. OpenBSD has it. But what it means is that if they're usually run in like 2-node HA environments where you have 2 nodes, one of them will be active at one time, you can yank the power of one and there'll be no change. So you have all these customers, your firewall still stays up, is the idea. You can use that technology at scale to provide an actual stateful firewall across the internet if you wanted to. It's caveat supply. If you are interested in this stuff, you can do this too. So big commercial routers will usually speak BGP. You can use a BGP speaker, and there are a bunch of people who are doing this for a variety of reasons. It moves some of the configuration and the updates and all that stuff into software, which is good. And you can basically say, talk to the transit provider and say, hey, to get to me, you actually go over here. And as long as that's on the same subnet, as long as you're generally speaking, there are caveats, there are exceptions, but generally speaking, this is totally valid. And you might want to do it. I wanted to mention Elixir. If you aren't familiar with Erlang and the Beam and Elixir, you should look at it if you're interested in anycasting, or more to the point, you're interested in distributed systems. It's really nice, soft, real time. So big names in the space are like WhatsApp, a lot of the betting software stuff. It's soft real time. It's real time as far as you're concerned, but it's not hard real time like going to talk to an electrical engineer real time. But it's real time. And it's meant to fail in the sense of like, oh, this thing happened. Okay, the entire system is set up to be process-based, and if the process fails, what do you do and what do you handle with? And as a result, it scales really well in an anycast environment. I'm going to give you a really straightforward example. So I have I'm currently on a VPN, and I'm coming out of Toronto. That's the reverse DNS, right? And so if I query that address, I get an IP address. In particular, so what I've done is my 3 nodes that are using, they're anycasted, they are going, hey, this is my actual IP address. So I queried it at the anycasted address, and just for the demo purposes, I set it up with a very, very, hey, look, I'm here, with the actual node IP address. And so you get 155, starting with 155. If I were to change this and say, I will go to Amsterdam, give it a second to actually do the connection. So now I'm coming out of the world in Amsterdam, okay? Same address here. It's the same curl request, right? It's the same IP address. It hit a different server. That's what this is. That's why you would use it. It's load distribution, it's not load balancing. It's at a layer that is lower than DNS in the sense that it's IP layers. So you could do this and then stack a quad A record on top, or multiple A records or multiple quad A's, and get your load balancers that way. There are people who do this in layers. So you have multiple anycast networks that start to basically, oh, I'm overloaded. They will like kill themselves, and traffic will stop flowing to them. 5, thank you. And then, basically you can create self-healing networks on the public internet. And it's worth mentioning, all this is based on internet routing tables, which is basically, there's a protocol for where traffic gets sent and why. You can influence the decision, you don't control it. So you have to handle the traffic. I think that was about it. There's a bunch of stuff that I can talk about if you'd like, but some preemptive questions. There was a very, very common misconception that this didn't work for TCP. Because what happens if the global routing table changes, right? So if I'm on a cell connection here, and Rogers, which is the ISP I happen to be on for that network, or their ISP decides to change the routing tables, that means that I'll suddenly talk to this other node over here, right? That will break TCP. It's a thing. But HTTP requests aren't that long. If you are handling long-lived TCP, you're a special snowflake. Like, most protocols are designed to handle resets. And it resets. It basically just hangs up the TCP connection because the other side is like, why are you sending me traffic? I don't know what you are, and sends a TCP reset. That's about it. I mean, I got a whole bunch of stuff about OpenBSD specific stuff, but like, it really doesn't matter for this crowd. So questions, comments, concerns about anycasting?